Good morning, children. Children, in our last lecture, we have started with our lesson number 7, lenses, from Science Part 1. And in our previous lecture, we have studied about the lenses, types of lenses, terms related to the lenses, and images formed by a convex lens and a concave lens. So children, in today's video, we shall be learning about sign convention, the power of lens, and also the human eye. So, let's begin. So children, sign convention. Now children, in our previous standard, we have learnt the Cartesian sign convention used for spherical mirrors. We have studied this in our previous standard. Now here, the pole of the mirror is taken as the origin and principal axis is taken as the x-axis. So the sign conventions are as follows. The object is kept on the left of the mirror. All distances parallel to the principal axis are measured from the pole of the mirror. All distances measured towards the right of the pole are taken to be positive, while those measured towards the left are taken to be negative. Distances measured vertically upwards from the principal axis are taken to be positive. Distances measured vertically downwards from the principal axis are taken to be negative. The focal length of a concave mirror is negative, while that of convex mirror is positive. So children, these are the sign conventions. Do you understand, children? Okay. According to the Cartesian sign convention, for convex and concave lenses, the optical center O is taken to be the origin. The principal axis is the x-axis of the frame of reference. So, the sign conventions is as follows. The object is always placed on the left of the lens. All distances parallel to the principal axis are measured from the optical center O. The distances measured to the right of the optical center O are taken to be positive, while those measured to the left are taken to be negative. Distances perpendicular to the principal axis and above it are taken to be positive. Distances perpendicular to the principal axis and below it are taken to be negative. The focal length of a convex lens is positive, while that of concave lens is negative. So children, have you understood the sign conventions used? Okay, let's move ahead. So children, now we shall be learning the lens formula. The formula which gives the relationship between object distance, that is U, the image distance V and the focal length f is called the lens formula. 1 upon V minus 1 upon U is equal to 1 upon F. Lens formula is same for any spherical lens and any distance of the object from the lens. It is necessary to use sign conventions properly. Okay, children? Now, moving ahead, magnification produced by lenses. Magnification is equal to the height of the image upon the height of the object. That is, where h2 is the height of the image and h1 is the height of the object. Therefore, m, that is magnification, is equal to h2 upon h1. Let us give this as 1. The magnification due to a lens is also related to the distance of the object and that of the image from the lens. So, magnification is equal to distance of the image upon distance of the object. That is m, where v is equals to distance of the image and u is equal to distance of the object. So m is equal to v upon u. Let this be equation number 2. So from equation 1 and equation 2, we have m is equal to h2 upon h1 is equal to v upon u. Understood, children? So, now we will learn power of a lens. For this, we need to perform an activity. Take two convex lenses of different sizes, lens A and lens B. Now take a single lens, lens A, and collect sunlight on the paper using this lens A. Adjust it to get a clear dot. So this is the position where we could have a well-defined spot of light. Now, after this, collect the sunlight, okay, and start the time. Note the time required. After a while, we observe that the paper starts burning. Now, note the time required. That is, it is the 9 seconds for lens A. Now, repeat the same process with the lens B. Again, adjust the lens where we could get a well-defined spot. Start your timer. After a while, we could see that the paper is burning. Now the time required now is, for lens B, it is 13 seconds. So what can we conclude from this activity? Yes, we could say that the time is different for both the lens. The time required in both the cases is not the same because we used convex lenses of different sizes. The capacity of converging the incident rays of both these lenses is different and thus the time required is also different. Got it? So the capacity of a lens to converge or diverge incident ray is called its power. The power of lens depends on its focal length. Power of a lens is the inverse of its focal length. P is equal to 1 upon F. If the focal length is expressed in meter, the power of lens is expressed in diopter. It is expressed with the letter D. 1 diopter is equal to 1 upon meter. If the two lenses with the focal lengths f1 and f2 are kept in contact with each other, so the effective focal length of lens combination is given by 1 upon f is equals to 1 upon f1 plus 1 upon f2. If the power of the two lenses are P1 and P2, the effective power of lens combination is given by P is equal to P1 plus P2. Thus, when two lenses are kept touching each other, the power of the combined lens is the sum of their individual powers, that is P1 plus P2. That is, the power of the combined lenses is equals to P1 plus P2. So now we will be learning the human eye. It is the most valuable and sensitive sense organ, and it is a natural optical instrument. The eye is nearly spherical in shape with a slight bulge in the front part. And it enables us to see the beautiful, colorful world around us. Isn't it, children? Let us discuss about the important parts of the eye and their functions. Cornea. The front part of the eye is covered by transparent spherical membrane called cornea. Light enters the eye through cornea. Iris. Just behind the cornea is a dark-colored muscular diaphragm which has a small circular opening in the middle. Pupil. Pupil is the small circular opening of iris. The pupil appears black because no light is reflected from it. The dark center in the middle of the iris. The pupil determines how much light is let into the eye. Understood, children? The next, it changes sizes to accommodate for the amount of light that is available. The iris regulates the light by adjusting the size of the pupil. Let us see how its iris regulates and controls the amount of light entering the eye. When the intensity of light is more or it is bright source of light, then the iris makes the pupil to contract, and as a result the amount of light entering the eye decreases. When the intensity of light is less or if the light is dim, then the iris dilates the pupil so that more light can enter the eye. Eye lens. The eye lens is a convex lens made of a transparent jelly-like proteinous material. The eye lens is hard at the middle and gradually becomes soft towards the edges. The eye lens is held in position by ciliary muscles. The ciliary muscles helps in changing the curvature and the focal length of the eye lens. Retina. The inner back surface of the eyeball is called retina. It is semi-transparent membrane which is light sensitive and is equivalent to the screen of a camera. The light sensitive receptor of the retina are called rods and cones. When light falls on these receptors, they send electrical signals to the brain through the optic nerve. The space between the retina and eye lens is filled with another fluid called vitreous humor. Blind spot. It is a spot at which the optic nerve enters the eye and is insensitive to light, and hence the name given. Let us discuss the accommodation of eye and power of accommodation. Accommodation of the eye. The process by which the ciliary muscles change the focal length of the eye lens to focus distant or near object clearly on the retina is called the accommodation of the eye. Okay, children? Power of accommodation. The ability of the eye to focus object lying at different distances is called the power of accommodation of the eye. Now, how does an eye focus object at varying distances? When ciliary muscles are relaxed, the eye lens becomes thin. Thus, its focal length increases and we see the distant objects clearly. When the ciliary muscles are contracted, then the curvature of the eye lens is increased and the eye lens becomes thick. Thus, the focal length decreases and we see the nearby objects. In brief, it is the adjustment of the focal length of the eye lens which enables us to focus an object situated at different distances. Understood, children? Now, least distance of distant vision, that is near point. Near point or least distance of distant vision is the point nearest to the eye at which an object is visible distinctly. For a normal eye, the least distance of the distance vision is about 25 cm. However, it varies with the age of the person. For example, for infants, it is only 5 to 8 cm. The far point of the eye. Far point of the eye is the maximum distance up to which the normal eye can see things clearly. It is infinity for a normal eye. Cataract. The crystalline lens of the people at old age becomes milky and cloudy. This condition is called cataract. This causes partial or complete loss of vision. It is possible to restore vision through a cataract surgery. Range of vision. The distance between near point and far point is the range of vision. Understood, children? Defects of vision and their correction. Let's see. The eye may gradually lose its power of accommodation. In such condition, the person cannot see the object distinctly or comfortably. The vision becomes blurred due to the refractive defect of the eye. Now, defects of vision is of three types. The first one is myopia or nearsightedness. Second, hypermetropia or farsightedness. And the third one is presbyopia. These defects can be corrected by the use of suitable spherical lenses. We have discussed these defects and their correction. First, myopia. The light from a distant object arriving at the eye lens may get converged at a point in front of the retina in the vitreous body. This type of defect is called nearsightedness or myopia. In case of normal eye, the light rays from the object fall on the eye and converge on the retina. In case of myopic eye, the light rays from the object fall on the eye and focuses the light at a point in front of retina in the vitreous body. Correction. To compensate this, we interpose a concave lens between the eye and the object with the diverging effect desired to get the image focused on the retina. So this is the correction we can compensate to. Next is hypermetropia. In this defect, the human eye can see distant objects clearly but cannot see the objects distantly which are nearby. This means the point of eye is no longer at 25 cm but shifts further away. In case of normal eye, the light rays from the object fall on the eyes and converge on the retina. In case of hypermetropic eye, the light rays from the object fall on the eye and focuses the incoming light at a point behind the retina. A convergent lens is needed to compensate for the defect in vision. So this is the correction for hypermetropia. Presbyopia. Now let's study this. What is presbyopia? Presbyopia is a common type of vision disorder that occurs as you age. It is often referred to as the aging eye condition. Presbyopia results in the inability to focus up close, a problem associated with refraction in the eye. How does presbyopia occur? Presbyopia happens naturally in the people as they age. The eye is not able to focus light directly onto the retina due to the hardening of the natural lens. Aging also affects muscle fibers around the lens, making it harder for the eye to focus on up close objects. The ineffective lens causes light to focus behind the retina, causing poor vision for objects that are up close. When you are younger, the lens of the eye is soft and flexible, allowing the tiny muscles inside the eye to easily reshape the lens to focus on the close and distant object. Understood, children? So let's have a quick summary for what we have learned today. Cartesian signs and conventions for spherical mirror. The object is always placed on the left of the mirror and light from the object falls from the left to the right. All distances parallel to the principal axis are measured from the pole. All distances measured to the right of the pole are taken as positive, and all distances measured to the left of the pole are taken as negative. The height measured upward perpendicular to the principal axis is taken as positive. The height measured downwards perpendicular to the principal axis is taken as negative. Understood, children? Lens formula for spherical lenses. The lens formula for spherical lenses is the relationship between the object distance u, image distance v, and focal length f. The formula is expressed as 1 upon v minus 1 upon u is equals to 1 upon f. Magnification produced by spherical lenses. Magnification for spherical lens is the ratio of the height of the image to the height of the object. Magnification is equals to height of the image upon height of the object. That is, m is equal to h1 upon ho. The magnification is also related to the object distance and the image distance. So it can be expressed as m is equals to h1 upon ho is equals to v upon u. Got it, children? Power of lens. The power of a lens is the reciprocal of its focal length in meters. So P is equals to 1 upon F, or F is equals to 1 upon P. The SI unit of power is diopter and denoted by D. 1 diopter is the power of a lens whose focal length is 1 meter. The power of a convex lens is positive and the power of a concave lens is negative. Okay, children? Next is human eye. The human eye is an important organ which reacts to light and pressure. As a sense organ, the mammalian eye allows vision. So a normal eye looks like this. Parts of a human eye. The front part of an eye includes iris, the colored part, cornea, a clear dome over the iris. Pupil, the black circular opening in the iris that lets light in. Sclera, the white of your eye. Iris, the colored part of an eye, controls light entering, and the functions are controls the amount of light entering the eye. Cornea, clear lens in front of the eye. It is transparent covering of the front of the eye, allows for the passage of light into the eye and functions as a fixed lens. The functions of cornea are it allows for the passage of light into the eye and also focuses the light. Pupil, it is the black hole in the iris where light enters. The function is pupil size is controlled by iris muscles. Got it, children? Sclera. It is a tough white skin made of tissues that covers all the eyeball except the cornea. Functions: it supports the eyeball and provides attachment for muscles. Retina. It is internal membrane, contains light receptive cells, that is rods and cones, converts light to electrical signals. Function: it converts light waves to electrical signals. Got it? Optic nerve transmits electrical impulses from retina to the brain, creates blind spot. Brain takes inverted image and flips it into so we can see them. Function: it transmits electrical signals from the retina to the brain. So children, with this we have come to an end of today's session. Hope you all have understood. Children, please watch the video attentively and then read the lesson. We shall see you in the next video with a new topic. Till then, take care. Thank you children for listening to me.